All right, hello and welcome to station 7. In this station, we're going to be working with various angle measurements, and we're going to use our equation solving skills to try to figure out how many degrees these angles actually represent. So in this picture, I see two parallel lines, and they're crossed by what's called a transversal. This line that cuts through the two parallel lines creates a bunch of angles around those two parallel lines. In this situation, I have two different angles. I'm looking at this angle, which is represented by 2x plus 19, and I'm looking at this angle, which is represented by x plus 23. Now, if I look at those two angles, I notice that they are the same measurement. They're equal. I can picture this little angle sliding down and lining right up with that little angle. So in this case, I have two angle measurements that I can tell are going to be equal. So what do? I take my two expressions and I set them equal. This must mean that 2x plus 19 is going to be equal or the same as x plus 23. Now that I have this equation set up, this looks just like my variables on both sides in station 4. So I'm going to slide a 1 in here just to remind myself that that little x is a 1x. And I'm going to get started by first moving my variable. So the first thing I'm going to do is subtract 1x from both sides. So I end up with, on this side, 1x left plus 19 equals 23. Then I'm going to isolate my variable, or get my variable by itself, by next subtracting 19. So I type into my calculator 23 minus 19, and I'm left with 1x equals 4. I can divide both sides by 1 as a final step just to finish it out, and I get that x equals 4. Okay, so that's all great, but I'm not quite done yet because the question is asking me to actually find the measurements of those two angles. So what I'm going to do is plug this number back in, similar to how I would do a check. So if x equals 4, I'm going to come up to this angle and say 2 times 4 plus 19 is going to be the measurement of my angle. 2 times 4 is 8. 8 plus 19 is going to give me a measurement of 27 degrees. Now I'm going to do the same thing on my second angle just to make sure that they're the same. In this one, it was x plus 23, so 4 plus 23, which again is going to give me 27 degrees. So my final answer is that these angles measure 27 degrees. X was still 4. I still got the correct answer for my variable, but I had to bring my variable up and plug it back in to find what my actual angle measures were. So when you see these pictures of angles, the first thing you could do is set them equal. That's kind of choice number 1. On the other hand, there will also be times when the angles are not equal. So if I scroll down here to the second problem, in this case, I don't have equal angles. I actually have 3 separate things. I have an angle that's being represented by x, I have an angle that's being represented by 4x, and I have an angle that's being represented by this 3x plus 20. So in this case, I can't set them equal. These are not equal angles. These are all different measurements. So instead, I need to look for something else that can help me. In this case, I see a straight line. AB is a nice straight line. I know back from my previous angle work that a straight line always adds up to 180 degrees. If I had a circle, it would be 360. If I saw a right angle, I would know that that was 90. You have to look at your picture. It depends on what they give you. In this case, they give us a straight line. So in this problem, I need to add all of my pieces, all of my little angle chunks up to 180 degrees. I know that the sum of them will be 180. So I'm going to start by putting all my pieces together. I know that the blue angle, x, plus the green angle, 4x, plus that pink angle, 3x plus 20, all together is going to add up to 180 degrees, all 3 angles together. So now I have some like terms to combine. So I have an x, a plus 4x, and a plus 3x. So if I want to slide my 1 back in there just to make sure that I have everything, 1 plus 4 would be 5x, plus 3 more would be 8x, plus 20 equals 180 degrees. Now, this looks just like my two-step equations that I did all the way back at the beginning. I'm going to put my train tracks down. My first step is going to be to subtract this 20 from both sides. I bring down my 8x and know that that equals 160. And then my last step would be dividing 160 by 8. Divided by 8. I type in 160 divided by 8 on my calculator, and I get x is 20. Okay, but again, we're not done. We don't want to stop there. We have to find our angle measure. So I'm going to bring this 20 up, and I'm going to plug it into each of my pieces. So the first piece says just x. Well, that's easy. That means that this little sliver is just 20 degrees. X is 20. I plug it right in. My next angle says 4x. 4 times 20, which would give me an 80-degree angle. And finally, over here in this pink section, I have 3 times x plus 20 more. So 3 times 20 would be 60, plus 20 more would give me an 80-degree angle. And if I wanted to, I could double check at the end and make sure that these three numbers, 20, 80, and 80, add up to that 180-degree straight line, and in this case, they do. So this is the second option for your angle equations. Sometimes you're going to have to add them up. It might be to 180 if it's a straight line, 90 degrees if it's a right angle, 360 degrees if you have a full circle of angles, or you might be in a situation like our first example where your two angles are the same angle and you're setting them equal. So it's up to you to determine which of these two strategies you're going to use. Do you have two equal angles, or do you have angles that add up to a certain sum? All right, get your worksheet and get to work. Make sure to ask your teacher for help if you need it.